I'm David Reaves from David Reaves Audio, and this is the web-based remote control software for the Zen 10 audio level controller. What we're looking at here is the metering for the gain. You see, in this case, we're using 5 bands of gain, and to the left means the gain is decreasing, and to the right of the 0, the gain is increasing. So this would be band 1, band 2, band 3, band 4, and band 5. The color and the position of the band indicates the amount of gain and the activity of the processing. The gain is being attacked or reduced when you see purple, but you won't see purple very often because the attack is very fast. If the gain is increasing, then that's the release function, and the release function indicates in green. Meanwhile, if the gain is not changing at all, then it's in yellow, the amber color, which indicates that the gain is within what's called the Zen Platform window. And that's the best part of this processor, is that it knows when to not process. As long as the audio is within the range that you want it to be, it won't add any gain or reduce the gain at all. It'll just leave the gain at a static level. So whenever you see the yellow happening, that gain in that channel is not being changed whatsoever, and the audio is also not being changed, and its sound will be identical in its dynamics to the incoming audio. The input is set to where we use a reference of -20. The -20 is the typical RMS operating range of the incoming audio. We operate at -20 inside the processor, so it's kind of our 0 dB reference for operation, -20 below 0 dB FS. And you can change that if you have an internal reference in your plant that is higher or lower than -20 below 0 dB FS. You can set the input reference to a higher or a lower reference. In this case, it will change the level according to where your normal 0 dB reference is. Here or here, it will increase the gain. Here, it will reduce the gain. And normally, we would leave it at -20. The balance control allows you to shove things to the left or to the right. On a static basis, it will just adjust the incoming audio to slightly left or slightly right. It's a maximum of 3 dB each direction. Normally, this is left at 0. There's also another control on the input that can finally adjust the individual analog and digital balance inputs. We have a high-pass filter, which is normally set at 0. It has a roll-off below 18 hertz, and if you turn it down, it rolls off at 40 hertz, 4 dB down at 40, or it boosts for 40 hertz by as much as 4 dB. And that adds a lot of punch on the very low end, kind of the thud sound of very, very low bass. But this is all user selectable. The output controls are similar, but here we have the analog control referenced to 0 dB dBu, and the digital target is also referenced to the 0 dBFS. This is an RMS level, -20 for the normal AES output and -20 for the Dante AES 67 output. The crossover is where we determine how many bands we want to use. If you just go to a single band, there isn't a crossover. But if you go to 2 bands, the crossover can be anywhere from 60 to 6,000 hertz. Normally, if you're just using 2 bands, you would probably want to put it somewhere around 150 to 200 hertz. These frequency locations are all 1/6 octave standard IEC frequencies, and they are set by this slider here. When we go to 3 bands, we will have 2 crossovers for the band 1 to band 2 and band 2 to band 3. Also, once again, these should be set to somewhere around upper mid bass, and then the middle of the mid-range range, lower mid-range here. The goal of these controls is to allow our processor to see roughly the same amount of RMS energy in every band. This way, the spectral balance won't change as the level changes. So if the audio fades, it doesn't force an obnoxious spectral balance change in its output. When you go to 4 bands, you have these controls settable to here or here. Once again, we're trying to get roughly the same amount of energy in each band. So we would adjust it accordingly. If there's more energy to the left, that is, that band is working harder, we would bring these 2 bands closer together, and it will reduce the energy in that band. And there's a safeguard here built into the crossover. You can't bring the 2 crossover frequencies closer together than 1/2 octave. So if this one is here, then the band 1 to 2 cannot go any higher than this, and the band 2 to 3 can't go any lower than that. It's locked to not be able to go, and this forces this at least 1/2 octave of energy in each of the bands, and doesn't allow either of the bands to have 0 energy, or a strange case where the lower crossover would be higher than the upper crossover. So this is just a safeguard. And then when you go to 5 bands, of course, you get the 5 frequencies. And once again, we want to set these bands as much as possible so that the general energy level of every band is the same. Each of the bands has the capability of changing the nature of the processing. The two ways to do this are stereo processing and matrix processing. If the band is set in the matrix mode, then the audio is controlled by its left plus right energy and its left minus right energy. If the band is set in the stereo mode shown here in green, then the audio is controlled by the left and the right energy levels, or a combination of the two, the higher of which normally will do the control. The bands that I have set up right here, I have the bottom band, band 1, set up as stereo matrix, but I've set it to mono. And this makes the left minus right go away completely in that band. So you see only one band being controlled in the first band, the lowest band. This allows the user to put 0 left minus right energy into the bass frequencies. It's useful on FM, particularly if there's a multipath situation in listening areas around the FM transmission. And by reducing the amount of left minus right energy, this clearly reduces the likelihood of intermodulation distortion when there's an event such as a multipath situation where there's lots of reflective audio, reflective RF coming into the receiver. And this is just kind of a cleanup thing. In the stereo mode, we can set up restrictions so that the left and right channels are allowed to change a little bit in relation to each other. This is the way band 2 is set up. I've set a restriction here of 3.5 decibels. This means that left and right bands can differ from each other. The gain can differ as much as 3.5 decibels before the gain will lock together and the higher band will control. In the case of this band, I've got it set to 0, and you can see that the two channels controls lock. They are totally in sync with each other. So there's no stereo stage wandering. If you go to where you allow a little bit of flexibility between left and right channels, there may be a stereo shift possible, but that's probably not that big of a deal if you're keeping the amount of allowed difference to be less than 5 or 6 decibels. For the controls that are in the matrix mode, you can see that we're in mono for the first band, so there's no gain restriction there. But for the top 2 bands, which we're using in a matrix, you can see this -6 tells us that the left minus right can never increase more than 6 decibels in gain above the left plus right. So this restricts the stereo stage from ever expanding any wider than 6 decibels greater than the left plus right. And this higher band is also set the same way. This is a very useful thing to allow a certain amount of gain enhancement on the left minus right, but to restrict it so that it doesn't go crazy in case of an incoming piece of material that has an immense amount of left minus right. It will reduce that. Input drive for each of the bands is pretty self-explanatory. The normal way to run this would be to leave everything at 0 and then use the crossover frequencies to determine how much gain is in each band. But if in the case of where you have a particular set of crossover frequencies you want to use, and the amount of energy in that band is going outside of where you would prefer it to be, you could either raise or lower the drive to that band to compensate for it. Normally, like I say, the default would be to leave things at 0, and then there's no difference in the drive for all 5 bands in this case. The ratio control is the amount of compression that happens with a variation of input. If there's a 3 decibel variation with a 3-to-1 ratio, the output will be 1 decibel. If you set it for 10-to-1, then a 10 decibel variation on the input will allow a 1 decibel variation on the output. The same goes for the left minus right. Normally, the left minus right will track with the left plus right. And if you change one, the other will go along with it. But if you want a different left minus right, once you've set the left plus right, then you can change the left minus right independently. So the left minus right can use more compression, more dense, and more active than the left plus right, and it builds the stereo energy a little bit higher, or less if you prefer. So we'll go back to the defaults. The RTZ is returned to 0. This is what happens when the audio goes away. When there's no audio coming in, then the processor looks at this and it waits for a period of up to 20 seconds, which is user adjustable. This is called the wait time, before it does anything. And what it does is, if the gain of that of any of the bands is at greater than 0, then it will slowly return that gain of that band up to 0, to where the overall gain for that band is back to normal, the default of 0 dB. And the speed of how fast this happens is what this right-hand slider does. The defaults are 10 decibels, 10 seconds of wait time, and a speed of 5. Each band has a release gate threshold, release timing, Zen Platform, and RMS Punch. The bands that are in the matrix mode have an additional set of controls for those bands. So I'll explain first what the release gate threshold is. This is for the situation where the audio coming in is low and you don't want to bring it up to full volume. You set your release gate to that location. And this would be -20 for normal audio. If something comes in below -20, the release will gate and it will stop the processor from bringing up or releasing in that band. The normal way to set this up would be to play music of a normal, consistent level that fits your program, and then make it so that it gates the release whenever the audio goes below that level, so that it doesn't bring up unwanted low-level audio. On the other hand, if you want to bring up audio at the lowest levels, then you can always go to a much more aggressive -30 below operating level of the gate release, which will allow the release to happen even if the audio goes considerably below the operating level. Release timing tells you how fast it's going to work. This is a logarithmic scale, and it's dB per second. Each band can go as fast as 20 decibels per second gain change, or you can set it to be as slow as 0.5 decibels per second, which is almost inaudible. And they're adjustable on a per band basis. And you can see the first band and the last 2 bands are in matrix mode because they're purple, you can see that. And so you have a separate release timing control for those bands down below. And the same goes for the gate threshold and the Zen Platform and the RMS Punch. The Zen Platform is the kind of the magic spot for this processor. This determines how wide the area is, the range of audio that the incoming audio can vary without using any sort of gain change. So if the audio remains within this range, let's set it to 10 decibels for all of them. Set it here, all the way to 10. Now you can see that the platform is almost constantly on. The audio doesn't get much variation because the audio that is coming in stays within this 10 decibel range. And if you go the opposite direction and make it a much smaller window, then you can see there's much more release activity. And it happens to make the gain change a lot more often, which can be a positive or a negative depending on what the programming that you're creating requires. So normally around 5, 4, even 3 is a relatively useful wide range of input level variation allowed. But at the same time, it does control when the audio goes outside of that window, and it will release if it goes below it, and it will attack if it goes above it. RMS Punch is basically an attack system. It accentuates the attack so that you hear more percussive sounds a little bit louder during that time of the attack, which is a few milliseconds, maybe 50 milliseconds. And so the punch control will accentuate these attacks and allow that to be a little more punchy. Normally, I would have it turned off completely, but I wanted to show the sound that it adds, because it can be a quite pleasant sound in small doses, and is a pretty useful enhancement. And of course, the RMS Punch is available on the bands that are being used in matrix mode in the left minus right. The output of the Zen 10 has variable gain for each of the 5 bands if you're using 5 bands of processing. The variation that you add here is a static variation. So if you turn the bass up 3 decibels, then that lower band will always be 3 decibels higher than the other bands. This may be what you want. On the other hand, it may not be what you want, and so you can set them all to 0, which is what I normally do, and I make most of my changes just using the platform and the release controls, because they basically do a similar function. I think to learn from all of this is that you have a lot of controls and a lot of ability to increase or decrease the amount of processing from different perspectives. The release gate threshold is going to stop the levels from coming up at low levels. The release timing will tell you how fast it's going to happen, and you can make that more active or not. The Zen Platform will set aside the area that you want to preserve dynamically, and of course, it's all of these are adjustable on a band by band basis, and the amount of punch will set the amount of the enhancement of the attack that you want. And since you can do the left minus right independently, you can build up a stereo image that is very consistent, and if it's really controlled a lot, you can then turn down its level to where it's sending in the left minus right that's processed to the output at a much lower level, and reduce the stereo spread. But at the same time, if you're using more processing, it will still sound very active.